In this video, we're going to look at the area of a triangle, and I want you to remember from geometry that the area of a triangle is 1/2 base times height. And I'm also going to label the sides of my triangle based on the letter of the vertex. So here I've got A, and here I've got B, and the whole side here would be C. And the first thing I want to do is, since my area formula deals with the base and height, I want to draw in the height from the vertex C, draw in the height of the triangle, label the height of the triangle H. Then the next thing I'd want you to do is to think about what's a trig ratio that involves the side length H and B and the angle A. So you're thinking about what trig ratio involves A, H, and B. Okay? You should have come up with the sine, since that was the opposite is H, and the hypotenuse is B. Okay? Solve the equation for the letter H. So solve the equation for the height of the triangle. Okay, so the traditional formula for the area of a triangle was what we wrote above. So that's up here. And now I want to replace H in my formula with the value I just came up with. And let's see what we end up with. By the way, I should also be replacing the base here with the letter in my triangle that refers to the base of my triangle. So here the height is drawn perpendicular to the base. So the base is letter C. So in place of B, I'm going to put the letter C. And in place of H, I'm going to put this formula here. And that gives me area is 1/2 the base, which we said was letter C in our diagram, times the height, which is B sine A. All right, so now I have a new formula for the area of a triangle when I know the angle A and the side lengths of that triangle that form the angle A. Okay, so as long as I have an angle and the sides that make up that angle, then I can use this formula for the area of a triangle. Okay, now I want to use the new formula to solve some questions. So in this case, Q is given as 10, N is given as 18, and the measure of angle R is 28 degrees. Now I could draw in the height, right, and calculate it, or I can just use my formula. So in this case, I want to use the formula. 1/2 times one side of the triangle times the other side of the triangle times the sine of the angle between those two sides that I just had. So between here and here, I have the angle R, which is 28 degrees. And then you would calculate that value. I'm going to go ahead on to the setup of the next question while you do the calculation. Okay, here I put a caution. The formula is for two sides and the included angle. Given an isosceles triangle with legs equal to 12, let me change colors here. Isosceles triangle with legs equal to 12, and with base angles each measuring 40 degrees. So in an isosceles triangle, each of these is a leg, and the other side is a base, and the base angles are formed with the base. Okay, so this is 40 degrees and 40 degrees, and the remaining angle would be 180 degrees minus the 80 that I used, so this would be 100 degrees. Okay, and my formula works for any triangle as long as I use the included angle. So I can't use 12, 12, and sine of 40 because this 12 and 12 don't make up that angle, they make up a 100-degree angle. So when I use my formula, it's 1/2 one side, an adjoining side, and the sine of the angle between the two sides. And again, I leave the calculation for you, so you would calculate that value. From this, I'm going to get what's known as the law of sines. And the law of sines comes from that area formula. So I'm going to write the area formula using different sides of my triangle. So here I have side length A, here I have side length B, and here's side length C. And I'm going to write my area formula 3 times using a different angle each time. So let's say I want to use angle C to start with. If I'm doing things relative to angle C, I need to use the side lengths that make up that angle. So I would say that the area would equal 1/2 A times B times sine of the angle C. Likewise, if I use angle B, then I'm going to use the sides that make up angle B. So I'd be using A and C. So A times C times the sine of angle B. And these values should be equal since I'm dealing with the same triangle. The area of that triangle is fixed, so whether I get it from these sides and this angle or the other sides should still be the same thing. So I have one more arrangement, that's if I use angle A. So then angle A would be 1/2 B times C times the sine of A. Now what I want to do is, now that I say that these are all equal, I'm going to develop my law of sines. First thing I'm going to do is multiply each piece by 2. So if their areas are all equal, if I multiply each of them by 2, they should still be equal. Okay, so I've got A, B, sine C. Here I've got A, C, sine B. Here I've got B, C, sine A. And now what I'm going to do is divide all of these things by ABC. And it doesn't seem to make sense until I see what my answer ends up being. Because I have the same factor, numerator and denominator, they cancel, and I'm left here with sine C over C. Here the A's cancel and the C's cancel, leaving me sine B over B. And finally the B and C cancels, and I'm left with sine A over A. And this is known as the law of sines. The ratio of the sine of the angle is to its opposite side consistent ratio for all angles and sides within a triangle. Sine of A is to little a as sine C is to C, as sine B is to B. That ratio is fixed, and this is true for all triangles. So SOHCAHTOA I could use for only right triangles, but this law of sines is for all triangles. We're going to do one example. We're going to do one example with the law of sines, and then we will save the rest for in class. Okay, so the first example, let's say that I know that angle B is 95 degrees, side B is 15 centimeters, and I also know that side A is 12 centimeters. I'd like to solve the triangle. solve the triangle again means find all missing parts. In order to use law of sines, I must always have an angle and its pair, so its opposite side. And then I'm going to use that to find my original ratio. So sine of 95 degrees is to 15 as. Then this side is the other side I'm given, and it is opposite angle A. So I'm going to do the sine of angle A over its opposite side, 12. Law of sine says that those must be in the same ratio, so now I'm just looking for angle A. So I need to get sine A first by itself and then get A by itself. So I'm going to multiply both sides by 12, and that gives me 12 sine 95 over 15 is equal to sine of A. And then to get A by itself, you would do the inverse sine of both sides. So the inverse sine of this, when you put it into your calculator, will give you the value of A. Once you have A, you're going to subtract to find C. So the angles of a triangle add up to 180, subtract to find C. Then set up your sine ratio again using angle C this time in order to get the small side C. Please do that before coming to class. We'll pick up from there during class.